Applying trig identities to evaluate trig functions. So for these examples, you already know one way of solving these problems, but there's another way we can go about it, and we can do it algebraically using our identities. So in example A, it says to let theta be an acute angle such that cosine of theta is equal to 0.8. So obviously not something on the unit circle. Find the values of sine and theta using trig identities. So first of all, let's just talk about the old way we could have done this. And don't forget, acute means that it is less than 90 degrees. So that means we're automatically in quadrant 1. So when we're worried about, say, all students take calculus, everything is positive. We don't really have to concern ourselves with that. So the old way of doing it is that we would have, we would have drawn a fraction. So let's start with the old way. So we would have wanted to think of that 0.8 as a fraction. So we would have said that cosine of theta instead of 0.8 was 8/10, which would mean really that's 4/5. And that is the adjacent side and the hypotenuse of a triangle. So we could draw ourselves a right triangle and say, okay, adjacent is 4, 5 is hypotenuse, this must be 3. And we want to find sine and tan. Well, sine would just be opposite over hypotenuse, and tangent would just be opposite over adjacent. That's the old way of doing it, and there's nothing wrong with doing it that way. However, these specific directions say to use trig identities. To use a trig identity, what we want to do is think about the different relationships. So we're given cosine. That's what we're starting with. If we're given cosine, we want to find sine and tangent. We want to think about what's the relationship between cosine and one of these. So one of them, if I look at my identities, is that sine squared plus cosine squared is equal to 1. So what I can do is plug in the information that I do know and solve for sine. So I have sine squared plus, and instead of cosine, we're going to do 0.8 squared is equal to 1. That's going to give us sine squared plus 0.64 is equal to 1. We'll subtract. So we'll get sine squared is equal to 0.36. And then we'll take the square root of both sides. And again, because it's acute and we're in this first quadrant, we don't have to worry about the plus and minus here. So that gives us that sine of theta is equal to 0.6. Okay, that's part of my answer. The other half says, what's tangent? Well, we know the relationship between tan, sine, and cosine. Tan is equal to sine divided by cosine. So that means that tangent is going to be 0.6 divided by 0.8. And when we simplify that, we get either 3/4 or 0.75. It's really just another way of thinking of this problem. All right, and the next one, it says to let the angle be, again, an acute angle, so quadrant 1. Tangent is equal to 3, find cotangent and secant. Okay. So again, the old way of doing this would have been to draw a triangle. We could have said that tan was 3/1, placed it in our triangle, and then found the rest of it. Or we can do it this way. So we have, we know tangent, we want cotangent. We do have a relationship between the two of those. I know that cotangent is equal to 1 over tan. So that means that cotangent will be equal to 1 over 3. Okay. The next thing we want is secant. So I want to think, do I have a relationship between secant and either cotangent or secant and tangent? And we have a relationship between secant and tangent, and that relationship is that 1 plus tangent squared is equal to secant squared. Okay, so let's replace tan with 3. So 1 plus 3 squared is equal to secant squared. That's 1 plus 9, or 10. We'll square root. Again, because we're in the first quadrant, everything's positive. We don't have to worry about plus minus. So that means that secant is equal to 10. Or sorry, root 10. Square root of 10. All right, for the next one, same kind of concept here, but we're given slightly different information. It doesn't say acute angle this time. So we are given secant is -3/2 and tangent is greater than 0, and we want to find all of the trig functions. So we want to find sine, and we've done something similar to this, cosine, tangent, cosecant, secant, and cotangent. All right, so let's fill in what we do know already. We know that secant is -3/2. So without any work, though it is a trig identity, we can really say that this is going to be -2/3 because we flip it over. The reason is that cosine is equal to 1/secant, which means that it's equal to 1/3², which is -2/3. Okay. We also know something, because we're given that tan is greater than 0, that means tan is positive. We know that secant is negative and cosine is negative, so let's think about what quadrant we're in. We can't be in the first quadrant because we have negative values already. But we want to be where tangent will be positive, and that is quadrant number 3. So tan should be positive, but sine and cosecant should both end up being negative. All right, so now we can take a look and see what sort of relationships do we have here. It might be easier to start with sine. So we know cosine, we can find sine. Sine squared plus cosine squared is equal to 1. Oops, theta is equal to 1. And I already know cosine. So I have sine squared plus -2/3 squared is equal to 1. When I square that, I have sine squared plus 4/9 is equal to 1, which means sine squared is equal to 5/9. And then I'll take the square root. So sine is going to equal root 5 over 3. Oops. Now, the only thing is I already know what quadrant I'm in, so it has to be -root 5 over 3. Okay. Now we can find cosecant very simply by using our identities here. So we know that cosecant is equal to, I'm running out of space here, but cosecant of theta is equal to 1/sine, which means it's 1/root 5 over 3. Well, actually negative in this case. So we get -3/root 5, or when we rationalize it, we get -3 √5 over 5. All right, and lastly, we need tangent and cotangent. So we know for tangent that it's sine divided by cosine. So that's going to be -root 5 over 3 divided by -2 over 3. The negatives become positive and the 3's cancel, so we're going to get root 5 over 2. And last but not least, we're going to need the reciprocal identity there to flip that over. So we know that cotangent is equal to 1/tan. So that's 1/root 5 over 2, which is going to be 2/root 5. And when I rationalize that, that is 2√5 over 5. Okay. And lastly, we want to use the values given to us to find all 6 trig functions again. All right, so we have sine. Let's give ourselves some more space this time. Cosine, tan, cosecant, secant, and cotan. And they tell us from the start that secant is -17 over 15. They tell us sine is 8 over 17. Okay. So we also can figure out what quadrant we are in pretty simply. All students take calculus. If secant is negative, cosine is negative. So we can't be in the first quadrant. And sine is positive, so we're in quadrant number 2. We should expect tan to be negative. All right, so let's find cosecant if we know sine. So cosecant is equal to 1/sine, which means 1/8 over 17, which means 17 over 8. Cosine is equal to 1/secant, so that's 1/-17 over 15, which is -15 over 17. Last but not least, we need tangent. Well, actually, we need tangent and cotangent. So tangent remember, is sine divided by cosine. So that's 8 over 17 divided by negative 15 over 17. The 17s cancel, so that's 8 over negative 15, or negative 8/15. Last but not least, you could do this a few ways. You could either say that cotangent was equal to cosine over sine, or you could just say that cotangent is equal to 1 over tan. It really doesn't make a difference. Either way, you'll get the same answer. So that'll give us negative 15 over 8.